Winnie, I request you mute your mic, but I can do it on my side. Let me do it here. Okay, you've done. So the topic is pressure objectives. So we will do objective number 1, definition of pressure. I hope you are taking notes, because we will be doing interactive session via Team, and then you will be doing quizzes on e-learning platform. So I will upload content and share. Right now I have no content uploaded, so there is no quiz, there is no content, but I have it offline already. It's just a matter of uploading. But online classes, I'm sure because of some challenges, I will be doing it almost 30 minutes or 1 hour. And we have started. So the topic is pressure. Are you seeing my screen, what I'm sharing? Hello? Are you seeing my screen?
No.
You are not?
Yeah.
Okay, let me work on it then. But it's already shared. Let me check. Yep, really. You are not, huh? Now you are seeing, eh? Is it visible?
Yeah.
Hello? Okay.
Yes.
Yeah, but you were quiet. So the topic, we have topic 3, which is pressure. And if you are able to take notes, please do. But I will share these notes. You will make your notes. I will share via WhatsApp or email. Then I will confirm if you have written these notes on your exercise books. But the topic is pressure objectives. We have objective number 1, definition of pressure. We will define what is pressure. We have also types of pressure. We'll have a list of them. Units of pressure. We have factors affecting pressure. We have another one known as pressure in solids. Another one, pressure in fluids, which is liquid or in gaseous state. We have application of pressure. And the last one, we do calculations or simple calculations relating to pressure. Calculation of pressure. And we start off. What is pressure? Any volunteer? What is pressure? Yep. Lucy? Lucy Kinya, I'm seeing you are. You can volunteer. Just definition of pressure. I have shared on my screen. So pressure can be defined in many ways. I told you this is physics. So you can use a formula which is pressure P equals to force over area. That is number 1. Number 2, we define pressure in terms of rho H. Rho GH. Rho GH means it's a formula of rho. Rho means density. And the formula of density, we have definition of density. It's amount of substance per unit volume or occupying space. So which is density equals to mass divided by volume. So it is rho, which is density, multiplied by G, gravitational force, multiplied by H. H is the height or head. So this applies to liquid or fluid. So pressure is defined as force exerted by an object on another object. So it's a force or force in newtons exerted by an object on another object. Number two, someone can define also pressure as force exerted by a fluid on an object. So the first one was object to object. Number two, it's a fluid on an object. Maybe a fluid on a container. Another one was an object on an object. It can be a block placed on a table. And the third one is force exerted by an object on a fluid. Kindly mute your mic. Yes, Peter Njuguna, you are raising your hand.
Yes, I was to define pressure.
Sorry?
I was to define pressure, but you already did.
Oh, I was fast.
Yeah.
Yeah, Sinclair. You have anything clarification? Jonas, Sinclair Jonas. You raised your
I'm
hand.
good.
I
I'm good.
Okay, Peter Njuguna, you may volunteer. What is pressure?
Okay, I can define it
Yes.
as force exerted given area.
Okay, April, dear.
Force
Yes, force.
exerted
Uh-huh.
in a given area.
Okay, force exerted in a given area. Yeah, okay, it may work. Yeah, force exerted in a given area. So, but you missed some key things. Which
Okay.
force is coming from? Yeah. Yeah, but it can
You
work.
must.
I'm saying, yep.
Okay.
Okay, that's good. Anyway, so it's a force exerted by an object or by a substance or fluid. It can be a ratio also, or divided by its area or surface area.
Okay.
Yeah, so we were on number 4 or number 3, which is force exerted by an object on a fluid. Number 4, someone may define as a ratio, because if force is divided by area, it means F is to A. F full colon A. So it can be a ratio of force exerted by an object to, remember ratio, you say a ratio of something to something. Yeah? So a ratio of force exerted by an object to its surface area. Its surface area. Units of force used in this formula, which is pressure equals to force divided by A. Units is Newton per. So force is given in terms of Newton and then divided by area. Area is given in terms of square meters. So number two, someone may define pressure as it's a product. So the first one, some of you may define in terms of pressure equals to force divided by area. So matter students or someone else may define in terms of rho GH. Rho GH. So he or she may say it's a product of density, comma, gravitational force, and height or head of a liquid. So that also can define pressure. The first one was in terms of force divided by area. The second one is in terms of rho GH. This is physics also, so you may put your formula and divine it, instantiate or initiate. Kama ile ya kwanza ukisema pressure equals to force over area, please divine what is P. It is pressure. Divine what is F, which is force, and their units. Force N, which is Newton. A, which is the area or surface area in terms of meter square. Na hapo utapata max. Or you divide by wordings. Kama you may say force divided by area, as we have said. Pressure can be given in terms of rho GH. And what is G? G is a gravitational constant or gravitational acceleration or gravitational force. And it is 9.85. Usually it's 9.8. Now the key units here, ukipewa gravitational force or as an acceleration, you understand acceleration is, units of acceleration is meters per square seconds. Distance divided by, or velocity divided by time. So it is given in terms of m per square second, in terms of acceleration. But in terms of Newton, so 1 kilogram, you may not term this, 1 kilograms equals to 9.8 newtons. So 1 kilograms equals to 9.8 newtons. So 9.8 newtons over 4 per kg over mass. So that is a definition of G. It's a 9.8 newtons over force per kg over mass, meaning 1 kg equals to 9.8 newtons. If you round off, mostly we use 10 newtons. 1 kg equals to 10 newtons when you are converting. Now, note on these units, E. This one of G. So it is N divided by kg. E. So it's N divided by G. We'll come tutaona hiyo units hii itatusaidia sana hapo. So we have divided pressure in terms of force over area, in terms of rho GH. So we now go to, let me enroll or change some students here. Rho GH. So we want, hello?
Yes.
Hello, yes. Pressure using the formula of force divided by area. Units ni gani? Units ni gani? Calculate pressure when using force divided by area. Units ni gani? Yeah, Peter Njuguna.
Yeah, Newton per meter squared.
Yeah, Newton per meter squared, because force is given in terms of Newton, and then area in terms of meter squared.
Yes.
Now, when you are using the formula of rho GH, rho is the density of the substance, and then gravitational force, which is 9.8, you may be given. Use G to be 9.8 or 10 multiplied by H. H is the height of a container. You will be given. And then G, have you noted G here? G units yake ni gani? Ni Newton per kg. Okay, so Peter Njuguna,
Yes.
you may volunteer also to tell us units of pressure when using rho GH.
Low GH.
Yeah, rho GH. Density multiplied by gravitational force multiplied by height.
Okay. Yani two.
Sorry? Oh,
No, that one.
and remember, I'm downloading the list, so please do share. All of you should, at least quarter of you should attend. I'm downloading participant, and I will be marking register. E-learning platform, there is a section you will be marking yourself register for attendance, but that one will be done next week. Right now I'm doing manually. I could have started with calling your names, but this time I will be downloading participant list here. Yep, Peter Njuguna, you may hold a bit. Anastasia, have a clarification? Anastasia?
Yeah, nimesema tu niweza mute hao wenye nini speaker yako iko sawa iko.
Sawa. Yep. Kama Dori.
Because they
Yep, let me mute. I shall mute. Okay. Peter, are you done? Peter Njuguna. I'm muting some people and then wanaendelea ku unmute. I'm doing it intentionally. Unless you want to raise something, just unmute and raise. It can be a question, comment, or any clarification. So, okay, any volunteer apart from Peter? Units of pressure when using rho GH. Ukitumia rho GH. This one here. Units of pressure. Peter, are you still there? Okay, let's go on. So we said pressure can be given by using the formula rho GH. So density here, which is rho, is given as mass divided by volume. And units of mass, as a unit or units of mass is kg divided by volume cubic meters. Multiplied by gravitational force. So here I said G is units second Newton per kg. So I just multiply N divided by kg multiplied by H. H is height, so it's a distance, or it's a length, measurement from a point A to point B given in terms of meters. So you cancel because meters is in numerator here and then meter cubic denominator. So you cancel mm, you upaki na meter square. Na in kg zinaenda, unapaki na Newton as a numerator and then meter square as a numerator. So still pressure you is given near GH, still unapeana in terms of Newton per meter square. This is the proof. Veronica. Veronica, just ask something, or you may mute your microphone now. So pressure, when using the formula rho GH, units zake pia ni Newton per meter square. But you have known how it came about. Si ati ni kitu tu unaweka tu, ni because of each unit of density divided by mass, which is kilogram, divided by cubic meters, divided by Newton by kg, which is gravitational force, multiplied by meter, which is height. And then mm cos, upaki na meter squared here, kg cos, unapaki na numerator as a Newton as a numerator, and then meter square as a denominator. So that is fine. Now we go to types of pressure. So we have different types of pressure, which comes about the reference pressure. So it's the same pressure, but now we are using reference pressure. But the same force we are applying, the same surface area we are using, same rho GH, density and everything, but now the result comes about from the reference pressure we are using. So types of pressure, we have number one, absolute pressure. So this pressure is equals to 0. And this pressure exists in free air in the universe. Hapa tu. So that is called an absolute pressure. So absolute pressure is a reference also. It's given in as pressure and then a short form of absolute, which is pressure, APS, which is absolute, equals to 0. So this is the pressure existing in free air in the universe. So that is called absolute pressure. So it's the same force over area, it's the same rho GH formula we are using, but now application area or the reference pressure, which is absolute pressure, which is 0, existing in free air. Number two, we have also what is called atmospheric pressure. This one, you know, ATM. So this pressure is created by weight of atmosphere. This one is surrounding the earth. Like the force exerted on earth's surface by the weight of atmosphere. So that's called atmospheric pressure, and always acts downwards, almost the same as weight. And this is important because in real life, this applies in real life situation. It can be exerted on a fluid or on a free body diagram. So initial for atmospheric pressure is given as ambient. So the pressure AMB. Pressure AMB. This is pressure or ambient. It's also ambient pressure. Or initial, which is pressure, and then subscript of A and B. Ambient pressure. The first one, absolute pressure, is given as pressure absolute. So the P ABS pressure absolute equals to 0, because that one is a reference pressure. Atmospheric pressure is pressure ambient. Pressure ambient is the same, also same as atmospheric pressure. Let me check. Yes, Florence. Florence, I'm seeing your hand raised. Unmute and...
I'm saying.
Yes.
I'm saying. You
Yep.
can't see the notes.
You can't see it?
The notes in the screen, they are too small.
Okay.
Yeah,
Let
thank
me
you.
enlarge. Sahi inaonekana?
No.
Okay, yep. Let me share. Tena uniambie sahi. From the current slide. Hapo?
Yeah. It's
Inaonekana?
okay. Thank you. Yeah,
Oh, welcome.
thank you.
So let me start as a preview also. So we started as this topic, which is pressure. Objectives number one. Objective number one, we said we will define what is pressure. We have defined in terms of force over area, in terms of rho GH, and then we are on types of pressure. Then doing the units of pressure, factors affecting pressure, pressure in solids, and the pressure in fluids, application of pressure and calculation. Number two, that's the definition of pressure. We define pressure as using the formula pressure equals to force over area, where P is pressure, F is the force in terms of Newton, units in Newton, area ni surface area of the object, units ni square meter. So this is a definition of pressure. Someone may use each, lakini usitumie sote. So it depends on diversity. Someone may use the first one, someone may use the last one, a ratio of force. Someone may write the formula itself and then initiator, which may say pressure equals to P equals to pressure, F equals to force, area equals to surface area, and then anapeana units. Anapata marks tena hapo. Also, someone may use rho GH to define pressure by saying it's a product of density, which is rho, multiplied by gravitational force, which is G, multiplied by height or head of the liquid, which is rho GH. Here, then we came here, we were proving why pressure, when we use the formula of rho GH, tunapeana tena in terms of Newton per meter square. Ukitumia force divided by area, that is Newton divided by meter squared, which is okay. Na ukipewa uitumie rho GH, units utapeana in terms of. So this was the proof. Density is given as mass divided by volume, and mass is given in kg, volume ni meter cubic, multiplied by Newton per kg, which is gravitational force units, multiplied by h is meters, and then we cancel hizo tukapaki na Newton per meter square. So pressure ukipewa ukitumia rho GH upeana tena in units ni Newton per meter square. Types of pressure. So we said we are using the same force, the same area, but now it depends on application or the reference pressure. So number one, we talked about absolute pressure. So this pressure exists in free air in the universe and is given as pressure absolute or pressure ABS subscript equals to 0. Number two, we talked about atmospheric pressure. So this is the pressure experienced on Earth's surface by the weight of atmosphere surrounding the Earth. And this one is also known as ambient pressure. So it's given as pressure AMB, pressure ambient. So, and it's also dependent on altitude. So the higher kienda juu, pressure increases or lowers. In a liquid, it depends on depth and height of a container. We will see in the next subtopic. So, and then we have also number 3, which is called differential pressure, or normally known as change in pressure. So this is the difference between the two pressures. You may be given pressure 1 and pressure 2, pressure A and pressure B. So there are differences, ndio inaitwanga differential pressure, change in pressure. So change in pressure 1, change in pressure 2, and it's given in terms of delta P, which is change. Change is given in terms of a triangle, and then P, change. It's symbolized as change in pressure. So it's differential pressure. You have pressure 1, pressure 2. So ukitoa tofauti yao, pressure 1 which is 40, the pressure 2 which is 60. So 60 minus 40, that is differential pressure. We have the last one, gauge pressure. Hiyo ni over pressure or exceeding pressure. Gauge pressure or exceeding pressure or over pressure. So it is given as the difference between absolute pressure and ambient pressure. So the difference between number 1 and number 2. Number 1 is absolute pressure, number 2 is atmospheric pressure. So there are differences, ndio utapata what is called exceeding pressure. So it is given as pressure subscript E. E stands for exceeding. Yeah. So pressure exceeding, or pressure over pressure, or gauge pressure. So ni pressure absolute minus pressure ambient, ndio utapata gauge pressure or over pressure or exceeding pressure. Now we go to next units of pressure. So number 1, we are sure of Newton per meter square. That's number 1 unit given ukicalculate pressure. So unit yake unapeana in terms of Newton per meter square kulingana na force na area you used. So ni Newton per meter square. Number 2, it's also given in millimeter per mercury. Normally you know this is 760 millimeter per mercury. Number 3, atmospheres. So you may give also pressure in terms of atmospheres, which is ATM. We have talked about Newton per meter square. Number 4, is it Pascal? I'm a Pascal. Okay, Pascal. That's also you can give in terms of PA, Pascal. There is another one known as PSI, pound square inch. PSI, which is pound square inch. And then the last one, bar, millibar. We have 200 bars, mostly used in medical gases. A cylinder, you may be given in terms of 200 bar. Oxygen concentrators, it's rated in terms of bar. So you need pressure yenye iko ndani. We have conversion. 1 Pascal equals to, we did this in class, which is equals to Newton, 1 Newton per meter square. So 1 Pascal equals to 1 Newton per meter square. 1 ATM